Hello everyone, welcome to our channel Simplified Computer Science Concepts by Professor Rutuja. Today we will be learning Maekawa's mutual exclusion algorithm. So let us begin. So this Maekawa's mutual exclusion algorithm is also called as a quorum based approach or a permission based approach. What is a quorum? So basically, if a site wants to enter into a critical section, it needs to take permission from a subset of particular sites. Then that particular subset is called as a quorum. It is a non-timestamp approach. It seeks permission from a subset of other sites. There are three types of messages: request, reply, and release. Request is a message that is sent to all other sites in the quorum or request set to get the permission to enter into the critical section. Reply message is sent from the sites in the quorum to the requesting site, and release is the message which is sent after exiting the critical section. There are certain assumptions and rules that are followed in Maekawa's mutual exclusion algorithm. That is, every process should belong to some group. If any process wants to enter into a critical section, then it will send requests to its group members and receive reply from the group members only. So it is not concerned with all other sites in the network, but it will be relating, or it will be dealing with only the processes that are there into its group. So the rules for process is that the intersection of two groups is not equal to none. So here if you see, this is the quorum. 1, 2, 3, 4 is a quorum for a particular process, and let's say this is a quorum for another process. Now these are two groups, we can say, and one of the requirement is that there should be at least one process that should be there in common in these two groups. So that is there. And any process, if you consider, it should be a part of any group, and single process cannot be considered as a group. So for example, if you say here P1 is equal to a set of 3 and 4 process, which means that this is the quorum. 3 and 4 is the quorum of P1. That means whenever P1 wants to enter into the critical section, it needs to seek permission from process 3 and 4 only. Similarly for P2, it needs to seek information from 3 and 5. And likewise. So this is the algorithm. We'll come back to it later. We will just start looking at the illustration. So initially there are 5 processes that are there, and each process has its own request set or a quorum. So for process P1, 3 and 4 is its quorum. For process P2, it's 3 and 5. For P3, it's 2 and 5. For P4, it's 2, 3, 5, and for P5, it is 2, 3, 4. So this is the quorum, or this is the request set of each particular site. Now what happens? Let's say P1 wants to enter into the critical section. So these are the request set or the quorum that are there. Now what will P1 do? It will first send the request message to the sites that are there in its quorum. So what are the sites in its quorum? That is 3 and 4. So it is sending a message to process P3 and it is sending a message to process P4. It will maintain a queue, and it will send itself into the top of the queue. That is R1, request 1. Now P3 and P4 will also maintain a queue. They will say that we have received a request from process P1. They will also maintain the queue, and request 1 of process P1 will be maintained at the top of the queue. Now P3 sends a reply, and even P4 also sends a reply saying that the flag is true. That means you can enter into the critical section. So now P1 enters into the critical section. Now how Maekawa's algorithm guarantees mutual exclusion? So here now initially P1 is into the critical section. Now let us say that P2 also wants to enter into the critical section. Now what is the quorum of P2? It is 3 and 5. So it will send the request message to process 3 and process 5. Now the queues are updated. The queue at P2 sends itself at the top of the queue, that is R2. Then at P3, initially it was R1, then R2 gets updated, and at P4 it is R1, and at P5 initially it was blank, now it is updated with the request 2. Now what happens? P5 checks which is at the top, request 2, so it immediately sends flag is equal to 2. That means P5 sends permission to P2 saying that you can enter into the critical section. Now P2 will not be able to enter into the critical section because it has not received the reply from P3. That means P1 is already there into the critical section, and at P3 request 1 is already on the top of the queue. So unless and until P1 sends a release message, P3 cannot send a flag is equal to true message to P2, and hence it cannot enter into the critical section. So see, P1 now sends release message to P3 and P4. So now the queue at P3 says that only R2 is at the top. That means now P3 can send flag is equal to true message to P2, and now P2 can enter into the critical section. So this is how it works. Now let us go and check the algorithm. Yeah, so requesting the critical section. So a site SI request access to critical section by sending request to all the sites in RSI. That means RSI is nothing but the request set, or we can call it as a quorum. On receipt of this request, a particular site sends a reply only if it hasn't sent a reply to any other site and received a release message from it. Else it gives it on the request queue for further consideration. And when a particular critical section will be executed, so a site enters the critical section only if it receives a reply from every site in request set or every site in the quorum. Then only it will enter into the critical section, otherwise it will not. Then releasing the critical section. So after execution of critical section is completed, site SI will send a release message to all the other sites in the request set, and when a site receives release message, it sends a reply to the first pending request that was there in the queue and deletes that entry from the request queue. So this is how the Maekawa's mutual exclusion algorithm works. So I hope you have understood this concept, and if you have any doubts you can post it in the comment box. Thank you for watching the video. Please like, share and subscribe to the channel Simplified Computer Science Concepts by Professor Rutuja. Thank you for watching the video.